Hi, Numberphile. My name's Andrew Valiente. We're going to talk about the tetrahedral molecule, specifically the angle between the molecule sticks. This molecule has 4 hydrogen atoms. They're all equidistant from the central carbon. And this is actually methane, which kind of makes it kind of smelly or kind of fun. So I'm an MIT engineer, and I want to talk about this channel. I love your channel. Your channel will love this problem. All right, let's go into it. All right, so here's the question. Tetrahedral angle, which is the CH4, which is methane. And I drew a little picture here. So we want to know what the angle is. If you look in a chemistry textbook, it will tell you it's 109.5 degrees. So we're going to see if we can calculate that. Notice I drew my picture and I wrote some axes already. So this molecule is up on the z-axis. And then these 3 others are kind of like below negative z, but split in these kind of weird directions. So we are not going to use trigonometry. We're not going to use geometry, and we're going to use vectors. So if you open like a high school algebra textbook and you open to the back cover or the front cover where you have all your identities, it's actually really, really hard to solve this problem using those identities. But if you solve it using vectors, it's actually incredibly simple and easy. With the trick to it, of course. Specifically, we're going to use unit vectors. So let's create our first vector. So A is up here, which has no components in the x and y and something in the z. So this is going to be 0, 0, 1. That's pretty easy. The B one, well, it's a little bit more complicated. Because this is 3 dimensions, it's split in the x and y plane, and maybe you could kind of line it up on one of the axes, but it's still not that straightforward. On the x and y, the z is a little bit different. The z component is actually easier to solve, and that's what we're going to do first. So the trick here is, or one trick, is we're going to use this kind of concept, or I don't know, conjecture or whatever. The sum of the forces is 0. If you can think of this molecule floating in space, all these unit vectors will pull with a force of 1 in all directions equally, and this molecule is perfectly balanced because this angle is the same angle between all the molecules. So the sum of forces is 0, and so we can simplify this to the sum of the forces in the z direction is 0. So in this picture, if I know that my A vector has a force of 1 in the positive z direction, I know that, so this thing doesn't accelerate or float away, I know that each of the bottom ones needs exactly minus 1/3 in the z direction. So I can now rewrite my B vector as something complicated in the x, something complicated in y, and minus 1/3 in the z. So now, do we need to calculate the something in the x, the something in the y? This is beautiful, because it turns out we don't have to, and I'll show you why. Well, back to high school identities. What's the most common vector identity? It's this one. A dot B is absolute value of A, absolute value of B, and the cosine of the angle between them. So this is what we have. We have 2 vectors, and we have a theta, all in one equation. So maybe we can solve this. So let's write our equation out there. There it is, 0, 0, 1 dot, something the x, something the y, minus 1/3 equals 1 times cosine theta. These are 1s because, remember, they're unit vectors, so I know that the magnitudes are 1. Now, well, what's interesting is because these 2 are zeros, I don't need to know what these are, because I know that anything times 0 is 0, so they just fall out. I don't even have to calculate them. So all I need to know is the 1 and the minus 1. So this product is minus 1/3. And I didn't have to know what these were. So that's minus 1/3 equals cosine theta. So say theta equals the arc cosine of minus 1/3, which is 109.47, blah, 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 blah. So that's my problem. Hope your channel would like it. You can credit me if you wish. It's Andrew Valiente. And I'm an MIT engineer, by the way. I love math. Your channel is wonderful. Thank you. Bye-bye.